story you tell yourself.
Yeah, but that term toxins
Right.
is so that is like there's certain things that people say where you know you're dealing with woo. Oh, this is some woo-woo bullshit here. And toxins is one of them. Cleansing and toxins. I'm going on a cleanse. And I'm getting the toxins out of my system.
Dude, scientists are just as guilty of woo as every other guy.
You think so?
Oh yeah, big time.
In what way?
Oh my God, man! Like there's scientists, and then there's philosophers of science.
Mm-hmm.
There's so much woo-woo in science. Even the most popular guys have woo-woo. They just never study the philosophy of science, so they don't really understand what they're saying per se.
Like, give me an example of woo-woo in science.
I'll give you a great example.
Okay.
There's this guy named Isaac Newton. Okay.
I heard of that dude.
Yeah, and you're asking him, hey, Isaac, why don't I fall off the face of the earth? And he's going to be like, well, Joe, there's this gravity, there's this force of gravity pulling you down to the earth. The earth has a greater mass than you, therefore there's this force pulling you down. We call it gravity. And then some guy comes around, his name is Zahabi, and he tells you, no, Joe, don't listen to that guy. I have another theory, way more, it's truer than his. I believe there are gremlins pulling you down to the earth. They have lassos, these infinite long lassos, and every time you're falling off the earth, they pull you. Every time you jump up and down on the earth, they pull you back down to the earth. You don't see these gremlins, they're invisible, but that's what's pulling you down to the earth. Now, how do you know who's right and who's wrong? Who's telling you the truth, me or Isaac?
Well, Isaac lived a long time ago before they actually had provable studies that could show you why gravity works.
Name me one of those studies.
Well, I'm not a scientist.
Well, let me break it to you this way. No scientist has a study to prove us that gravity works.
Really?
That's the whole thing. That's what's scary about how we talk about the universe.
But they understand that gravity is in relation to the size and mass of objects. So the moon is smaller, therefore it has 1/6 Earth's gravity because it's 1/4 the size of the Earth. There's a standard formula that they can follow.
There's a correlation. Now, my theory of gremlins, which obviously I don't believe in, right? I'm using mythological language to make it really don't somebody misquote me that I believe in. You know.
Firas Zahabi believes in gremlins. He doesn't believe in gravity. He's a gravity denier.
Exactly. Well, there's less mass there's less atoms. The moon has less atoms, therefore less gremlins, less of them pulling you. My gremlin theory correlates with the gravity theory exactly. But I'm using a mythical language just to point out that every type of force we're talking about is an inference. It's something we project out there. We don't actually see gravity. And later on, Einstein debunked gravity, right? What do you mean by he debunked gravity? Isaac was totally wrong. Isaac's explanation of why you don't fall off the earth was totally wrong.
Well, what did Einstein do to debunk it?
Einstein taught us that a new theory, a new hypothesis, that gravity is a pushing force, not a pulling force. See, Isaac Newton, he debunked Aristotle. First, we used to believe what Aristotle used to say. Aristotle used to say, look, this thing has a natural place. It has to be stuck to the earth. That's its natural place. The force is within that one thing. That's why it doesn't fall off the earth. So when Aristotle saw a bird fly, he said, look, it has levity. Its natural state is to be in the air. The force that it carries it up in the air, it's within it. It's within the bird itself. Isaac Newton came around and said, no, that's totally wrong. No entity can move itself. It's only a force that's applied. So let's say you're walking. Isaac Newton would say, you're not pushing yourself forward. You're pushing the ground beneath you backwards. And the ground is pushing you forwards. So every action is opposite equal reaction. So when I run, I'm really pushing the ground behind me. It sounds like he's splitting hairs, but he's saying something actually very profound. He's saying you're pushing the earth behind you, and the earth is pushing you forward. There's a reaction there. So what they do to illustrate that to kids is they take like a train track, they elevate it, and they turn on the train. And then you see the train track starting to spin underneath the train. And it's showing you, look, the train is pushing the train tracks back. And the train tracks are pushing the train forward when they're connected to the ground. So when I put you on a treadmill, you're pushing the treadmill behind you. The treadmill's not pushing you forward because it's spinning along with you. But if I put you on the ground is pushing you forward now. So for every action, there's an opposite equal reaction. I'm sure you've heard this. Then Einstein comes along and says, no, that's totally wrong. Well, when it comes to gravity, okay, when subject of gravity, he says, because Isaac Newton says this, look, the force of gravity is in the earth. The earth has this invisible force, this magical woo-woo thing. And that's what his contemporaries said about him. That's what his peers said. He said, oh, you're appealing to magic. What is this gravity thing? It's non-corporeal. It's not material. It's not made of a substance. Is this magic? And he was like, yeah, it's this force. You can't feel it. You can't detect it. It's just observable in nature. And for 300 years, everybody believed that. And then Einstein comes along and says, no, you guys are totally wrong. There is no mythical force called gravity. It's a pushing force. So really what he says is, sorry, let me get a sheet of paper here. Make it really, really simple. And I'm going to put it in a nutshell here, okay? But
okay.
He says, look, Einstein says, look, space and time are one. Space is actually a thing out there. It's actually the space between me and you is an actual physical thing. He says the sun is so heavy that it dents it. It makes like a toilet bowl. And the earth is bumping around in that toilet bowl because space is actually curved. It's curved like this. Space is curved because the sun, imagine I put a bowling ball on your bed. Your bed's going to indent.
Right.
That toilet bowl shape, the earth is flowing around that toilet bowl shape. So it's a pushing force, no longer a pulling force.
So the weight of the earth is pushing down on space.
Exactly. It's bending space, literally. Its mass is bending space. Now, Isaac Newton thought light travels in a straight line only. And to prove this, Einstein said, look, light will bend. If I'm right, light will bend. So they observed the sun during an eclipse and they saw that the light bends. Light does not travel in a straight line. This is another belief that was debunked. I mean, how many scientific beliefs are debunked? Countless. Or overturned, because a scientific fact is not a mathematical fact. They're two different things. A scientific fact can never go higher than hypothesis. If somebody understands the philosophy of science, he understands that every single scientific fact is not equivalent to a mathematical fact, 1 + 1 = 2. A scientific fact is always subject to cross-examination and new evidence. So have you ever heard of Thomas Kuhn? He's very famous for that, right? We have a paradigm. So during Aristotle's time, he had a paradigm. He thought the sun goes around the earth. It was an observational scientific fact. Every day he saw the sun go around the earth, literally. He said, look, guys, I'm using my senses to observe the sun go around the earth. And then one day we find out, no, that's an optical illusion. It's not true that the sun goes around the earth. It's the earth goes around the sun. Scientific revolution. Every scientific fact we have, or theory, including gravity, because gravity became the law of gravity. It was no longer the theory of gravity. It was so accepted, it became the law of gravity. Today, we don't understand gravity as Einstein understood it. As Isaac Newton understood it. We understand it completely backwards, literally backwards now. And that's true with every scientific theory, because science is always subject to new evidence coming to light.
Right, but the difference between Isaac Newton living like whenever the fuck he lived, it was a long ass time ago,
300 years ago,
versus the science that we're dealing with today, like science today. But what woo woo do you see in the science of today?
The biggest culprit,
yes,
randomness. See, it's funny because I heard this conversation with Sam Harris on randomness, which I loved, by the way. You did a great job. I thought it was a great conversation. However, he was giving you, in my opinion, two contradictory ideas. He was telling you, look, the world is determined, but also there'll be random events. And I found
that he was actually talking about determinism versus free will.
Right.
Yeah. So the idea being that you don't necessarily have free will, that everything about your decisions and what you're going to do is based on your life experiences, your genetics, all these variables that are essentially out of your control. So this idea of free will is an illusion, which is a really complex conversation, and I think you could see it in both ways. I think you do have a certain amount of control of your decisions, and I think you are also shaped very much so by your past and your genetics and your interpretations of those events. What are those interpretations of those events, though, and why do you make those determinations? Who's in your head pulling the gears? Like, what are you?
I'm a hard determinist. Like, I'm a very hard determinist. Like, I'm like determinist extremist. So,
but do you believe in free will?
I also believe in free will, which is tricky.
Yeah,
which is tricky.
But I think that's
it's true.
Upon
I think they're both
further examination, I think there is something that allows people to. I mean, what takes a guy who's 500 pounds and all of a sudden he goes on a keto diet and starts running and starts walking, and then he sends you a picture on Twitter. I lost 179 pounds in 6 months. You're like, holy shit! How the fuck did you do that? Like, that guy has some fucking will, man. To say that that's his whole life. And his life experiences and his genetics, it's like, yes, I could see what you're saying. I could see that he had enough because of his life experiences and that it led to him making this change. But there's a tremendous amount of will involved in that. And to deny that seems like you're denying the spirit of human beings.
Well, let's look at it this way, okay? Real
Okay.
quick. Let's look at it. Okay, let's say I crumple up this piece of paper. And I'm going to catapult it.
Okay.
And it landed there.
Right.
And now I'm going to reset the entire universe. I'm going to reset every molecule of air, every fiber in this paper. You're going to be in the exact same spot. The whole universe has been reset. And I fired it again. Is it going to land exactly where it landed the first time? Or is it going to land somewhere else? I've reset the universe. The Earth, every molecule of matter in every particle of matter in the universe has been reset.
With the same amount of force.
Everything is identical.
I would assume if the same amount of space and the same amount of air, you would land in the same spot.
Infinitely precisely?
I don't know.
Well, I've reset everything perfectly.
If infinitely precisely you throw it the exact same way and it lands in the exact same dirt with the exact same resistance,
It's the same thing.
I would assume it's infinitely precisely going to land in the same spot.
If randomness is a force at work in nature, why didn't it factor itself into our little experiment here?
Because your little experiment's impossible.
But that's irrelevant. It's a thought experiment.
But it's not a thought
It's not
experiment because you're recreating the whole universe.
Right, but it's not logically impossible.
Right. Well, in that case, though, with the variables that you presented, yes.
Okay. But where's randomness? Where's this force?
There's no randomness if you're recreating the entire Earth in a very duplicatable way. That's not randomness at all.
What is randomness? That's the thing. There is no randomness.
Right.
Randomness is when a human being can no longer compute all the factors. And we use an expression called randomness, meaning, okay, I rolled this dice, it landed on 7 randomly. Why? Because I couldn't compute all the variables. So,
okay, I see what you're saying.
So randomness is kind of it's an illusion that we project onto the world. So Laplace, one of the greatest physicists in history, okay, Simon Laplace, he says, look at a billiard ball table. Okay, if you tell me which way you're going to break the billiard balls, if you tell me what velocity and what angle you're going to hit the cue ball, I could tell you where every single ball is going to be on the pool table. That's what Laplace says. Okay, he's a phenomenal thinker. And he says, why? Because I'm going to take that table, I'm going to turn it to a math. I'm going to take the weight of the ball, the friction of the table, the density of the bands, the gravity of the earth. Excuse me. I'm going to take all those variables. I'm going to put them up on this board here. All I need to know is how hard you're going to hit the ball. And I'll tell you precisely where every ball is going to land. Now, somebody who doesn't know mathematics or geometry is going to look at that table. When he sees the break, to him it's going to seem random. But randomness is really a reflection of his ignorance. He's not able to compute all this information. That's why Laplace says, to God, the world is not random. To somebody who has information, the world is not random. That's why he says, it's very important, that's why we're so determinist, because we believe that what's happening right now is a byproduct of the past. The past caused this happening right now. The past was out of your control. If I reset the universe and let it play all over again, identical circumstance, you would drink that exact same amount of coffee you had today. You would have made you would have married the same woman, you would have had the same kids, you would have had the same t-shirt on right now, you would have the mic at the same distance, everything would be reset. So when we look at the world through the eyes of physics, they say the causal line is complete. The causal line is complete, meaning where is this space for randomness or free will? We don't factor it in. The only time we do factor it in is when we look at ourselves inwardly. But when we look at the world objectively as a third person, so there's two views. There's the internal view, first-person experience. We don't believe in determinism. We have free will. That's first-person experience. Third-person experience, I'm studying Joe. All I see in Joe is billiard balls. So when you have a thought, it's all billiard balls hitting one another. And if I had an infinitely precise calculator, according to Laplace, I could tell you where you're going to be 5 years from now, what you're going to be doing. Why? Because I'm seeing one billiard ball hit another. It's just take that pool table experiment and make it the greatest pool game in history. There are countless atoms. There are countless billiard balls striking into one another. Somebody can calculate the world of physics and tell you where your hand's going to be. Laplace says, I'm going to tell you where your hand's going to be in 5 years from now. But you don't know my personal choices I'm going to make. That's irrelevant. He'll tell you that's irrelevant. Why? Because he sees the billiard balls moving inside your mind, so to speak. Now, Leibniz reconciled the two. Because, see, for instance, when I'm living in the first person, this is my intuition. I'm like, hey, I grabbed that cup of coffee. I had this internal experience that's outside of physics. So Leibniz gives a great example. He says, look, if I was really, really tiny and I'd walk around your mind, I would see blood flow. I would see neurons firing. I would see all sorts of biological interactions. But I wouldn't see anything of consciousness. I wouldn't see your thoughts. I wouldn't see you thinking about your wife, hearing your child's voice, thinking about what you want to have for dinner. I wouldn't see any of that. I would just see billiard balls hitting one another. However, now that I'm having this first-person experience, there's something we call intuition, this first-person experience itself. You're having this spiritual type of transcendent experience. What it's like to have a thought, what it's like to be me. So for instance, I see that cup of coffee, I desire the cup of coffee, and I drink it. Science has no information about my conscious experience, my intuitive experience. Science is not absolute. It cannot tell me everything about the universe. It can only tell me about the billiard balls. It can only go so far. At that point, it has to stop. Because it doesn't have, our senses cannot sense the conscious experience that we're having. The conscious experience is only known intuitively. So first-person experience. So Leibniz says this. He says, look, you look at the world. When we study the world, we're all seeing billiard balls hitting one another. Nobody argues about that. However, our intuition is telling us that's all untrue. We have the ability to move our own hand, desire something, grab something, eat something, consume something, make a choice. And he says, how could they coexist? Because remember, in reason, for me to accept something as logically true, I have to eliminate every other possibility. So he found one possibility that till today it's never been refuted. He says he calls it the twin trains. So picture two trains, okay? They're going up and down, side by side, traveling at the same speed. They look like they're connected to one another, but they're not. They're just synchronized. Every time one goes left, the other one goes left. One goes up, one goes down. And so when Leibniz tells you, he says, look, when you reach for that cup of coffee, the universe had already decided millions of billions of years ago that was going to happen. Your intuitive sense just coincides with it perfectly. And he said that's what he calls the twin trains theory, the correlation theory. That your desire to grab that cup of coffee doesn't affect your hand, does not move your hand. That would be impossible. That would be something non-physical moving something physical. So he says that they're just correlated perfectly. When you ask him, how do they correlate so perfectly? He says, well, God, it's like God took the greatest pull shot in history. This is Leibniz. He's the guy who invented calculus, the binary code. You know, like all our computers today work because of Leibniz.
That to me is a hard sell.
Yeah, so most people can't wrap their mind around it.
Yeah, it's a hard sell. And first of all, a woman created the first computer code.
He invented the binary code.
Binary code.
Binary code, not computer code, but it's based on binary.
Now, when he's saying this, that your desire coincides with the universe having this, that seems like a lot of woo. That seems like quite a bit of a stretch.
That's the interesting part. Tell me why.
Well, why would the universe have a plan for you and your movement?
Well, he's saying God. He's saying God directly.
Well,
go ahead.
Prove that.
Okay, that's a great argument. That's a great objection.
Why would you say that it would be God?
This argument wasn't to prove God. This argument was to tell you that this is a possibility. Why you have free will is true, and so is determinism.
Yes.
Because can you deny free will? Aren't you having a direct experience of free will?
Well, the only denial of free will would be determinism. The only denial would be that your idea of free will is an illusion. You are really shaped by the momentum of your past, your genetics, life experiences, all the variables and the way you've absorbed emotions and interactions with people, and that these have flavored your very being to the point when presented with an obstacle or an opportunity or a thing, there is a predetermined solution in your mind for whatever the situation is. That's determinism.
Okay, so let's
I should say action rather than solution.
Let's take a step back and look at what Leibniz is trying to say. Okay. He's trying to say, look, there's three ways of knowing something. And yeah, you have to understand, this is a brilliant human being. Okay? And many men have said the same thing throughout history. So, but let's just at least entertain him.
Okay.
He says, look, you know something empirically through your senses. Okay? You touch fire, it's hot. Then you can know something deductively. 1 + 1 = 2 via logic. Then you can know something intuitively, meaning direct first experience. Okay? So let's say you tell me, I don't know, I've had, coffee tastes great. You don't know that deductively or empirically. The sensation of coffee tasting great is known intuitively, direct, meaning there is no interpreter. In philosophy, we have something called the egocentric predicament. So right now, you're experiencing this entire room within your consciousness, right?
Mm-hmm.
I might be outside of your ego, but I'm occurring right now in your consciousness. Can you see the difference?
I'm perceiving you
yeah?
in my consciousness.
Yes.
Or with my consciousness, which is connected to my senses.
Is there anything you can perceive outside of your consciousness?
That's a weird way of saying something.
It's impossible.
Is there anything, but perceiving outside of my consciousness, meaning not being not conscious, but yet still perceiving.
No, when you perceive something, it has to be within your consciousness.
Right. You have to, or with your consciousness.
Right. It cannot be outside of your consciousness.
So even if something touches your skin, you're consciously recognizing that it touches your skin.
The egocentric predicament is more about your whole universe is made up of your consciousness. You cannot sense anything or experience anything or get any information outside of your consciousness. Like Kant was very big on this. He's like, look, this is called idealism. The whole world is happening inside your head, right? Supposedly. Like, for instance, you see this cup of coffee. They're going to say, oh, the light clusters hit the cup of coffee. It goes in your eye. Your eye gives your brain a signal. Your brain interprets the signal and creates this universe around you. It creates this image. The theater of your mind, yeah? Mm-hmm. Can you experience anything outside the theater of your mind?
Very difficult to argue that you could.
It's impossible.
Yeah.
According to all the philosophers in history, we cannot. This is called the egocentric predicament.
But what about subconscious?
That will be still happening inside your conscious mind.
So subconscious is still somewhat conscious in some way.
Yes, it would be whatever you would perceive would be happening in your conscious mind.
It would just be outside of your standard awareness.
Now the scary thing is that we make a lot of inferences. And that's where the woo-woo comes in. Everything is woo-woo. You think just everything outside of science is woo-woo. Science is just as woo-woo as everyone else.
You keep saying that, but I don't understand why you're saying that because you haven't made a good example.
Okay, well,
the only example that you said was that they changed the way they look at gravity when new information was presented.
Right.
That doesn't equal woo-woo.
Gravity was woo-woo. It was a magical force. My
you're talking
theory
about gravity in terms of people that didn't have phones. They didn't have cars. They didn't have paved roads. I mean, you're dealing with a very primitive notion of what gravity was. It was a very interesting idea that has since been proven to be true.
False. Gravity, Newtonian gravity, has been proven to be false.
But gravity is still real, right?
We're using the same word for a completely different idea.
Okay.
So Newton's gravity was magical. It was an appeal to magic.
Okay.
Here it is. Let me make it clear.
Gravity is different than Einstein's gravity, and that Einstein's gravity is what's been proven, right? We know now that light does bend around the mass of the sun, which is one of the reasons why we have a hard time seeing asteroids that are coming from behind the sun, because the mass of the sun actually bends space-time around it to the point where it distorts our view.
It's our new narrative. It's not proven. You can never prove a scientific fact past the level of hypothesis. It's weird. I know it sounds strange, but
what do you mean past the level of hypothesis? If you can prove it in studies and tests and show, you still don't buy it.
You have not eliminated every other possibility.
Okay.
So it's not the same as a logical fact.
But how is that woo?
This is understood in the philosophy of science. It's comfortably accepted. It's not anti-science. Like, I'm not trying to say anything.
No, I know you're not. But you're saying that science has so much woo, and I'm not seeing the woo part.
Okay.
What I'm seeing is the necessary testing and the idea of incorporating new data and changing beliefs and ideas.
Again, this is it's a bit of a difficult thing to wrap your mind off in one day, but you have to think about it, and throughout time, it becomes clearer and clearer.
Okay.
When we observe the universe, all we see is pattern and regularities found in nature. That's it. We don't see actual physical laws. The physical laws are bookmarks inside our mind. We see the same pattern over and over again, and then we attribute a physical law. But that physical law doesn't exist out there. So here's a great example.
Okay,
let me give you a great example. Okay, let's say I'm about to flip a coin. Okay? Mm-hmm. Now, you're going to tell me it's probably going to land on heads or tails. Yeah? Mm-hmm. do you know that logically, or is it based on your history with coins?
I know it logically and based on my history of coins.
Perfect. I'm arguing you don't know it logically. You only know it on your past history. Okay, so pay attention to this. This is a little bit weird. This is we gotta go slow. It's very weird.
Okay.
It's very it goes against our instincts. Okay, erase all your history with coins. You've never seen a coin before.
Okay.
And I flip it.
Right.
And now it turns into a butterfly. You've never seen a coin before. It doesn't surprise you. You're like, whoa, turned into a butterfly. Mm-hmm. Then I flip a coin 100 times in front of you. 100 times it turns into a butterfly. Now I'm going to flip the coin the 101th time. You're going to be like, I bet you it turns to a butterfly. That's how we express science. We see the patterns and regularities, then we predict them. Science, this is a little bit, this is a good way to put it. Science is the faith, it's faith that the future will behave like the past. Science is faith that the future will behave like the past. So now you've developed a faith that this coin will flip into a butterfly, and now you can predict it.
Wouldn't you say that science is the use of measurement to understand matter and things around us? I wouldn't say that it's using the past to predict the future. I would say that if you know that fire melts lead at a certain temperature, and this is provable, and then you can show this over and over again. Here's what we know about fire. It reaches a certain temperature. When lead reaches a certain temperature, it melts. It changes its form. Whereas if you want to do that same test to carbon-based steel, it requires far greater temperatures, and then we know that there's variables in matter. But
Okay.
this is something that you can prove and show. There's no woo to that.
Okay, water boils at how many degrees?
I think it's 250.
In Celsius,
220?
in Celsius, it's 100 degrees Celsius. I don't know about Fahrenheit.
Oh, you Canadians with your wacky metric system.
Is that a scientific fact?
Is it a scientific
Yes.
fact that water boils at
Yes.
a certain temperature? Yes.
Actually, no.
It's not?
They can boil water now. Water can resist boiling up to 200 degrees Celsius. If you put it in a certain atmospheric pressure and suspend it in a certain liquid, if you change the circumstance,
Suspend water in liquid?
they suspend it in a particular liquid that's not heated or cooled.
All right.
It's not supposed to. It doesn't affect the temperature of the water itself. And now water can boil at 200 degrees.
Okay, so you're doing something different to water.
That's the thing.
You're taking it outside of the normal Earth environment. So the variables also include Earth's environment.
Agreed. But water doesn't inherently boil at 100 degrees. It's not a fact. But we believed it to be a scientific fact. We believe that water, if it gets to 100 degrees, is boiling. It's going to behave this way. As a matter of fact, no. There are many other things. That fact has been debunked. And there's countless amount of facts.
But wait a minute. Is that the fact's been debunked? Or is that when you add in sufficient external variables, then water takes longer to boil because of these variables playing into the properties that we already observed with water?
That's why whenever we have a scientific fact, there might be new information coming to change our view. Change our view of this fact.
Right,
Now,
but this is not necessarily new information. What this is new additional...
more precise information.
But what you're talking about with water, you're talking about additional variables. Like, that's just more science. That's not woo.
Okay, well, here's some woo.
Okay,
because we talked about gravity was woo. Okay, randomness was woo. Okay, because we cannot find one instance of actual randomness. The causal line is complete, as Laplace would say. There's no randomness in the world.
So the randomness idea is just our inability to calculate unbelievably difficult variables.
Exactly. But it's a projection of your ignorance.
Right.
If you knew, it wouldn't be random. So for instance, I can't remember who coined the term, but they say, the man who says the tallest mountain I've ever seen is the tallest mountain. He's making himself the measure of truth. I measure truth. If you take that perspective, you're the center of truth. I'm truth. There's nothing outside of me that's true. Then you see randomness everywhere. However, if you believe in correspondence theory, that truth is independent of me and you, which I think most of us will agree, then randomness doesn't exist in that context because randomness only depends on you and when things are true outside of your beliefs.
Right.
Let's take another classic woo term. Again, this is very advanced philosophy. I know it sounds crazy, okay, but this is what the greatest thinkers in history, report. Okay, what they've written down.
Okay.
Okay, you see this, you see a knife. Okay, let's look at Aristotle's theory of knives. Okay, so look at this knife. I show you a plastic knife. I show you a wood knife. I show you a metal knife. I show you 5 different knives. And you're like, they're all knives. All of them are knives. You point to them and say they're knives. Aristotle says, look, they all share in one something, let's call it the essence, that makes them all knives. Would you agree?
The form.
They all share. If I draw a knife on a paper, you'd be like, he just drew a knife.
Okay.
That knife on the paper shares something with the knife made of steel, the knife made of plastic,
Okay.
the knife made of wood.
The form.
There's something about it. We call it the essence in philosophy.
Okay.
The form might be confused with what Plato says, because Plato had a whole thing about forms. But let's call it, for now, essence.
Okay.
If you change the essence, you change the thing. So if I take that plastic knife and I melt it, you'll be like, it's not a knife anymore.
Right.
Why? What did I do? You changed that thing about it. That essence, right? Now, that essence, does it exist out there in the world, or is it only in your head? You made it up.
Well, by calling it essence, you're confusing me. So I would call it the form.
Okay,
the form of it exists in culture. It exists in our understanding of these objects and their useful shapes.
It's your idea of knife conforms to that knife out there.
Where's that knife? Oh, here.
That's a great, bring it out.
You can see it.
Great.
That's obviously a knife.
Yes.
Right? You recognize it.
Yes.
I recognize it. That's a knife.
Yeah, I totally agree.
It's like
my model of knife.
That's a knife.
Yeah. My model of knife, that fits my model of knife.
Mine as
Beautiful.
Well. But there's some weird looking knives out there too.
Sure. And there might be a knife where we don't agree. That's a knife. You think it's a knife. I don't agree. I think that's a sword. I'd reached the level of sword.
Right. Yeah.
Right?
Like a
we might have a different. That's great evidence that it's something in our minds.
Mm-hmm.
It's not actually objective.
Right. They get to the certain length.
It's
and you're
subjective.
Like, yeah.
It's subjective. Right. Okay. Let's look at matter now. Matter is an inference of the mind, just like the knife is an inference of the mind.
In terms of subatomic particles and atoms and.
Watch this. You see this cup?
Mm-hmm.
You see this bottle?
Yes.
You see this clock?
Yes.
You made an inference. They all share one thing. What do they share? All of them share one thing. What is that thing they share? They share this thing called matter.
Okay.
But that was an inference, just like we inferred the essence of a knife. Matter has never been observed in nature. Matter is a byproduct of our mind.
So when you see a tree, you're not seeing matter.
There's no matter. There's only, not that I'm inferring matter. I'm observing an image.
Right.
But I'm inferring the matter. The matter is a mental construct.
Is it a mental construct, or is it our inability to see things smaller than what is necessary for our survival? Like, we can't see atoms. We can't see subatomic particles. We can't see them with the naked eye. But we understand through science that they exist.
How do you understand that they exist? Are you saying that matter exists out there independently of your mind? Is matter objective, or is it dependent on your mind to exist?
It's not dependent on your mind to exist. It's dependent upon your mind to observe. You need your mind to be able to observe matter.
Okay, so matter...
But if you didn't exist, do you think this table would exist?
That I don't know.
Right. But what would you guess?
I would guess that all I know, if I'm going to use Occam's razor, you know, if you've heard of Occam, if I'm going to go to the extreme with Occam's razor, I'm just going to believe what I observe.
Okay.
And kill all the woo-woo. Kill it all.
You have had loved one die, right?
Yeah.
Everyone has, right? Do you assume that when they die, the universe is still the universe?
What do you mean, still the universe?
It's like the world is the way they are. I mean, the way it is. There's trees and grass and dirt, and this person dies.
Mm-hmm.
The trees and grass and dirt, they don't change. They're still the same thing.
What do you mean? The nature of the tree would change?
No, I'm saying if you love someone and you know this person and they are no longer with us, all the things around you, like this coffee cup and this knife, they remain the same. They don't change.
No, they don't change.
Why would you assume that it would be any different for yourself? If you weren't here, why would you think that this table would not exist or the microphone would not exist?
That's a great argument. I'm not saying that it wouldn't. This is what we call hard objectivity. Something that's hard objectivity exists without any human mind in existence. If all human minds were dead, whatever exists still is what we would call, philosophers called, hard objectivity. Now we have objectivity. So for instance, let's look at George Berkeley's example, because that's such a great question. Look at a triangle, okay?
Okay.
Picture a blue triangle.
Okay.
Picture a green one. Picture a black one. Picture a white one. Can you picture one with no subjective elements? Meaning, because color is subjective, right? Color is a construct of the mind. So if I was colorblind, this shirt would be a different color to me than it is to you.
Right.
However, there would still be one shirt. It would
Right.
be objective to a certain degree.
Okay.
So a triangle has three sides, 3 corners. It adds up to 180 degrees. We all agree. Whether you're colorblind, it doesn't matter.
Right.
There's no subjective element to how many points does it have. Nobody's going to come in and say, to me, triangles have 4 sides.
Right.
You'd be like, that's not a triangle. There's not 3 angles to that.
Right.
You've gone past analytical understanding. Okay, so George Berkeley says, can you picture a triangle without any subjective element, without any color? Let's call it color to make it really simple, really, really obvious. Can you picture a triangle without any color?
You would have to have it in contrast to something so that you could see it. Like if you had say if you had a purple curtain like what we have behind us, and out of that purple curtain we cut a triangle, even if there was no color, even if it was just clear, you would be able to see. You'd be able to differentiate between that shape.
But you needed that purple curtain
to differentiate.
Right. So we cannot have it without subjective element. This was Berkeley's point.
Okay.
Exactly what you said.
I see what you're saying.
Beautiful. Every objective thing we've observed in the universe is made up of subjective elements. Even when you draw the number 1 on a blackboard, it has to be a color. It has to be something.
Okay.
There has to be a contrast, like you said.
Okay.
It's beautiful. You said it beautifully. All our objective elements are mental constructs. 3 sides, the idea of side is a mental construct. The idea of a point is a mental construct. The idea of 180 degrees is mathematical. It's happening in your mind somewhere.
Right,
it's not out there being
provable.
observed.
You can draw it, and I can see it, and I can repeat it, and you can teach it to me, and I can teach it to someone else. Like they may be mental constructs, but
Yes.
they're provable mental constructs that are repeatable. So we think
We're in
of them
agreement.
as a real thing.
We're in agreement that mathematics is a mental construct and is true. It's by definition true.
So it's both a mental construct and true.
Yes, but it's not out there in the world. It's within.
But if you make a triangle on the ground, it's in the world.
The numbers are in your head, and the subjective element is in the world. There's a 2-way streak.
The subjective element is in the world, but it's a triangle. So
yes.
how's it in your head?
Because when you look at a triangle, the subjective elements, when you observe them in your mind points out different objective elements of that triangle. But it's dependent on your mind.
By that argument, the entire universe is dependent on your mind.
Absolutely, no doubt about it. If we're going to use Occam's razor,
Yes.
but not everyday language, we're using
Right.
Occam's. Let's take away everything we're not sure of, everything that has a doubt. Get rid of it.
Okay.
Get rid of everything with a sliver of doubt. Like, you ever heard of
Well, the problem
René
is
Descartes?
matter itself has a sliver of doubt.
Absolutely.
Well, when you have subatomic particles that, they exist in 2 different states simultaneously, they're both spinning and still. They're in super states.
Berkeley would tell you those are images of subatomic particles. They're not subatomic particles independent of your mind.
Well, I had a conversation with Sean Carroll about it, who's a physicist, and he made it
familiar.
even more muddy to me. I thought it was crazy before I talked to him, and then when I talked to him,
He's brilliant.
He's brilliant. He's essentially saying that subatomic particles don't blink in and out of existence. It's just it's the way we're looking at them, and that they exist in this just bizarre state. But they exist in this state in a way that it's very difficult for us to use normal language to sort of explain.
Exactly. That's the true issue. But you know what?
I might have fucked. He's probably listening to this. If he is, he's like, "You fucking dummy! You ruined what I said again."
You know what? One great conversation. I heard a conversation between Jordan Peterson and Sam Harris.
Oh, that conversation about truth?
I loved it.
Oh, that drove me crazy.
I think we could do better, though.
Yes, I think they could have done better, too. They needed a moderator.
Yes, exactly.
Yeah,
I think they need to get to know
mud.
each other personally first.
Yes, they never met, by the way.
Right. That's fireworks, right? That was such a great conversation. But here's my question: what's the difference between knowledge and belief? Because a lot of what we said is kind of muddy. Okay, let's make it super. Let's make the waters crystal clear as much as possible.
Okay.
What is the difference between knowledge and belief?
Well, the belief that the gremlins are pulling down on people, which is why we have gravity, that would be a belief.
No, they're both beliefs.
Well, that's...
Gravity is not knowledge; it's belief.
Okay, but we're talking about gremlins. I was going to say, that's knowledge, or that's a belief.
Belief.
Knowledge is if I throw water on you, you get wet.
I would say that's belief.
It's a belief.
Yes.
So maybe one day I throw water on you and you show me that you're Jesus, and the water just goes right through you and it doesn't
The reason
exist?
why you believe water will make me wet is because it happened in the past. And you think that the future is going to behave like the past. Just like Aristotle saw the sun go around the earth, and he thought that this is going to happen every day.
Well, he didn't understand.
I understand. It's optical illusion. Let me
right.
give you, let me
but
give
what
you,
I understand
let me
what
give you
water is, though. It's H2O.
Okay.
I throw it at you, you get wet.
All flamingos are pink.
They're not.
They're not. We didn't know that all the time, did we? Then we went to Australia. They don't have the same food source. They don't have the same food source. They're black here. They're white here.
Yeah.
They have a different food source. Flamingos are not inherently pink. A scientific fact can always be overturned.
What's this, Jay?
What if somebody had that never
look at this. You threw water and didn't get wet.
Yeah, but this is not. It's just because it's a certain coating.
Right. I got you.
But if he's got that over his body, he's not going to be able to breathe.
Okay, how about this? You've never seen fire before. You've never seen fire.
Okay.
You've been being warmed by electric blankets your entire life.
Okay.
Then you see a flame. And you don't know, can you know that flame is going to burn you if you touch it logically? Or is it only via experience through history? Developing a history, a relationship with fire. It burned you once, it burned you twice. You're like, hey, I think the future is going to behave like the past, so I'm not going to touch that fire again.
There's people who know that fire burns you and they've never been burned by fire because they went to school and they learned from people who explained the properties of fire, what it is, how it works, what temperature it operates on, how it's different depending upon the color of it or what's burning.
Borrowed history. It's still history.
Borrowed history? How so?
You learn from my mistakes of touching fire.
Okay.
But it's still known via experience, via history.
Well, it's known via science if you explain exactly what the elements of the fire are and how it works and what it burns at and what temperature specific things need to burn at. You don't have to get burned to know that it'll burn you.
No, but that's how we discovered fire burns, by testing it. Not via logical deduction.
Okay, I see what you're saying.
It's only history. Science is patterns and irregularities found in nature. We observe nature. We see these patterns and irregularities.
Right.
We have no idea what's causing them.
Well, wasn't that Descartes' original idea about science in the first place, was using measurement to sort of understand nature?
Well,
wasn't that one of his original concepts of establishing science in the first place?
No, his original concept was, look, science is doubtable. He said that. Science is doubtable, no doubt. It's called Cartesian doubt, an extreme level of doubt. He says, those are all beliefs. I don't have any knowledge. What do I know? Because knowledge means zero chance of being wrong.
Okay.
Zero chance of being wrong. Give me one scientific fact you truly trust 100%.
Okay. If I take a match and I take a yellow piece of paper from this particular notebook, I will light that motherfucker on fire with that match. That's a fact.
Okay. That's a scientific fact?
Is it?
No, it's a scientific fact, but it's not higher than hypothesis. It's just a hypothesis you have. Why? Because every time you've seen a fire touch a piece of paper, it burned it. So you're relying on your historical experiences.
Okay. So
it's not deductive.
You're essentially saying there's no scientific fact possible.
Only to the level of hypothesis. This is not me talking. This is Thomas Kuhn.
I understand what
He's saying, look, we have two phases in science. Standard science and then a scientific revolution. What's standard science? Well, whatever the flavor of the day is. Let's say today it's evolution. And then he says, look, every piece of information we receive, we interpret it through that lens. He called it a paradigm. We look at the information through the lens of evolution. So it makes sense. It fits right here in our story of evolution.
Right.
And then he says, look, a small amount of contradictory information is going to pool slowly. It's inevitable, he says. And then we're going to ignore it. We're going to sweep it under the rug. Everything doesn't make sense. We're going to sweep it under the rug. And then one day, that level of information, that amount of information that doesn't fit in any way with our theory, our current theory, is going to pool and pool and pool and pool until one guy comes around and says, no, we had it backwards or we had it wrong. It's this. And now all this new information fits in the new theory. All the old stuff fits and all the new stuff fits. And that's called the scientific revolution. And he says science is always going through a normal phase and then a revolution phase. And man is becoming more and more precise. But we'll never reach the level of past hypothesis. Why? Because science is based on our faith that that the future will behave like the past. We only know things via experience, via our history. So when I flip that coin, you have no idea what's going to happen until I flip many coins in front of you. Or I give you if you trust me and I tell you listen, I did this experiment, here are my results, and you trust me, you just take it for granted. You take it on way of authority.
I agree with everything you said. I still don't see where you're saying science has so much woo.
Okay.
Or science has as much woo as healers or crystal suckers or.
Listen, I don't believe in crystals in any of that.
I know you don't.
I don't. I have a higher standard of skepticism.
I'm missing the woo though.
Okay. The woo is when we project physical laws. Combustion, electricity, gravity. These are all appeal to magic. Can you demonstrate these physical laws? Or are they byproducts? Are they inferences you made in your mind because you've seen a certain pattern over and over again? That law doesn't exist out there in the universe. It's only a bookmark. It's only a name we have for a pattern we've observed in nature. It's pretty heavy stuff, I know.
It's only a name for a pattern that we've observed that exists in nature.
Exactly.
So that means you can't label anything ever. Because everything is just a pattern that we've observed in nature.
Exactly. Everything is a pattern.
So there's no
logic behind it.
Nothing
there's
is
no
real.
logic. We give an explanation. We give a narrative to it.
Okay.
But that narrative is just our paradigm. Thomas Kuhn would say, that's the shades you're wearing.
Okay.
That's you Kant said it beautifully. He said, look, you have pink tinted glasses. You could have blue tinted glasses. But whatever glasses you're wearing, that's the song and dance. That's the story you tell yourself of why those things are happening the way they're happening.
Okay.
The truth of the matter is, all we're seeing is one pattern happening over and over again.
So what this is essentially is an intellectual exercise. But the reality of our ability to come up, well, not ours, obviously, but super smart people, come up with the very technology that we're using right now to broadcast this podcast means that they have figured things out, that they're provable, and that you can use science to determine what frequency things need to be, how much electricity you need, what kind of components can take the image and project it through the power lines and through the internet cables and all the different things that we need to be in place to provide the electricity, to provide the internet connection. That's all science. So this is
it's predictive. Science is predictive.
Right, but these are all things that are not just observable, but they're repeatable.
Right. The patterns.
So where's the woo?
Here's where the woo is, okay? Our explanation for why it happens, the laws of nature, are woo.
It's not woo. It's our words that we use to describe repeatable things.
Okay, which force of nature are you referring to? Let's pick one. Look at randomness. Can you show?
I don't think that's a force of nature.
Okay,
I agree with you that randomness, the idea of randomness.
Okay, pick one. Because they use it. They say it's evolution, a natural selection via random selection.
Temperature. Okay.
Okay. What causes temperature? I observe temperature like you. I believe temperature exists. What causes temperature? We don't know.
That's true. And
we don't know.
You and I don't know.
And
we would have to talk
to
some. They don't have any idea what causes.
They can only tell me about the patterns and regularities. That's it.
That friction causes certain things. That the magnetic pull of the sun on the earth causes certain temperature shifts, and these are recognizable and repeatable, and they understand how to measure them.
Mm-hmm. These are all just patterns and regularities found in nature.
Right.
And they're giving them names and explanations.
I see what you're saying.
These names and explanations can be debunked later on. I put them in the maybe pile, plausible pile. But this is listen, I know it's frustrating, but the philosophy of science, this is it. The cause and effect, we do not observe cause and effect. We do not observe one thing causing another. We just see A and then we see B. It's a bit difficult, but imagine this.
We see A and we see B. We don't see
the causal connection. Because if we did see the causal connection, you would know what happens when I flip that coin. You could have predicted it. You could predict what's going to happen when I touch fire.
I would have to know exactly how much force you're exerting on your thumb to flip that coin. I would have to know what altitude we're at to understand what the atmosphere that this coin is going through. I would have to know the weight of the coin. I would have to know the position of your thumb on the thing.
Okay.
It's like what you said about the billiard balls. That is true, that if you could calculate the exact amount of friction on the cloth and the table, the amount of polish that are on the balls, the amount of force, you'd have to have all the balls in exactly the same spot. But this is not possible today. Today, if you set up a table and you set up, let's say, just say 9 balls, and you told me you were going to know where every ball was to the millimeter, I would say, I will bet you $1 million you're wrong, and I would be right every time. You're never going to get it.
Why?
Because you don't have the ability to calculate all those variables.
But it's theoretically possible.
And it's also the physical change of the amount of force that you drive when you break those balls varies. And if it varies even slightly, it's going to change the way. So a person just doing it with their body is not capable of that kind of precision.
If we got a robot to break.
Even if you got a robot to break, you would have to have those balls in exactly the same spot. And they don't usually sit that way because the cloth has fiber in it. And it's wool. It's a worsted wool. And that worsted wool moves and shifts and bends. And it flattens out in some spaces. And other spaces it gets dirt and debris and chalk.
Understood.
There's too many variables.
So because we cannot compute all the variables, I'm with you. We can't maybe...
Right.
We can create it with a slight margin of error.
Right.
There'll still be a margin of error. That's why Laplace said, I'd need a divine calculator.
Yeah,
he says, because I would have
epic.
to even round off the numbers. So I'll be slightly wrong.
Right.
But the argument is that if we had all the variables, and that's a big if, it's logically possible. It's logically coherent with the reality that we see.
Yes.
Randomness is by the wayside. It's a figment of our imagination. We project it when we cannot compute. But if we could, this is objective outside of us.
Right.
The truth is outside of us. It's not dependent on me and you, how we see the world.
So randomness is based essentially on our inability to calculate variables. It's not on an actual law itself.
Yes.
Yeah, that
so
makes
when
sense.
when we say that's random, it's woo-woo.
Right.
It is, in the strictest way of the word. Now, every logical law. Now, this is what hurts people. But I love science. Look at me. I'm a lover of science.
No, I believe you do.
I'm a science addict. Okay, I read all the books. I'm fascinated by science. Let's say I take object X, and I throw it at a window. What's going to happen?
I don't know.
You don't know. Have any experience with object
Right.
X?
I don't know what object X
Why
is.
Why can't you deduce it? Why can't you deduce what's going to happen?
Well, if I had more information.
You need experience. You need a history with object X. You need to get to know object X, interact. You cannot deduce it.
Well, you would write down all these different variables. You would find out what people have learned from the past about these variables, and that would be science.
Exactly. Science is the history of patterns and regularities. It is not deduction. It is not logic. It's a type of logic we call inductive logic. This logic is the faith that the past, the future will behave like the past. So the patterns and regularities we see in nature, we say, look, if these happen often enough, we can recreate these circumstances often enough, we predict it'll happen in the future.
Right.
We have a faith that it'll happen again in the future. There is no logical reason why it does. There is not one single logical reason why we don't fall off the face of the earth. Every explanation we give ourselves is just a narrative. It is always subject to reinterpretation. However,
with the change in variables, like
even
shifting of the Earth's magnetic poles, or
I gave you a ridiculous narrative, the gremlin one,
right?
Just to show you. Look, I know you don't believe in mine. I don't believe in mine either.
Right.
But I'm doing the same thing Isaac did, and I'm going to correlate my gremlins theory as far as he can correlate his gravity theory. He used the word gravity. He made it sound better. He made it sound less ridiculous. But the truth of the matter is, he's throwing his hands up in the air saying, look, I don't know. Let's just call it gravity. This is a way to think about it. Now, his contemporaries laughed at him. They said it's an appeal to magic. And then when people started wearing those shades, those paradigms, they're like, hey, it makes sense. If you just believe in gravity for a second, it explains all this ballet of celestial bodies and how they move. But really what he discovered was a pattern, and he gave that pattern a name. But does that force exist out there? Well, not according to Einstein. He came up with a different narrative that fits the evidence even better than Isaac Newton did. But it's still a narrative. It hasn't removed all the other possibilities. For something to be true, without a doubt, for it to be knowledge, not belief, there has to be zero doubt, meaning no other possibility whatsoever. That's knowledge. So can you know something that's untrue? You cannot know something that's untrue. You could believe something that's untrue. Knowledge means that this is known, there is no possibility of doubt. That's why Descartes was such an important philosopher, because he gave us one thing that we know, the cogito. Have you heard of the cogito?
I don't remember what it is.
I think, therefore I am.
Oh, okay. That's what it is.
So what is it that we know for sure? Because it's funny. There's two great philosophers that I've read that went through a crisis in their life. One of them was Imam Ghazali, a great Arabic philosopher, and one of them was René Descartes. And both their writings are very, like, it's amazing. Why? Because they go through this crisis. They go through, what do I actually know? What's not? Because they came to this exact same conclusion that, hey, it's all song and it's all an explanation. It's not proof. It's all a narrative. It's all a point of view. Science keeps getting refined and changed.
With more information.
What we believed yesterday gets taken out from underneath us. Today's paradigm is going to be shifted again 100 years from now, 1,000 years from now. What can I grab and be like, this is true. Nobody can ever take this from me. That's going to be called knowledge. So it all comes down, like at the end of the long journey of Cartesian doubt, it was so extreme. The philosophers gave it a new name. They call it Cartesian doubt. They call it modern philosophy. So philosophy is thousands of years old. Descartes comes, writes a book. He wrote 6 chapters in 6 days. And he was like, what do I actually know 100% without a doubt? Nobody could ever question me. And he said, look, I believe in the cogito. What's the cogito? I think, therefore I am. So he goes through a long process. You know, if we have the time, we'll go through a little nutshell of it. So he says, look, when I put a straw in a glass of water, my eyes tell me that the straw is bent. Right? Because the reflection of the water is bent. The reflection of the light off the water is bent.
Yeah.
He says, look, my eyes lie to me. Aristotle thought the sun goes around the earth. His eyes lie to him. Our senses lie. You know, he talks about if I put my hand in cold water, then I put it in tepid water, it'll seem warm to me. But that's just my bias, my inability to tell you what my instruments are not accurate enough. So he said, okay, let's put empiricism or senses by the wayside. It cannot give us truth. It cannot give us truth. He says, what about deduction? What about math? Analytical knowledge. 1 + 1 = 2. Believe it or not, philosophers also disagree with a lot of mathematical beliefs. So for instance, here's a big critique of math, okay? 1 + 1 = 2. We all believe it. But the critique is that 1 + 1 is another way of saying 2. There's no actual information you ever gave me. Mathematics is just one way to sum up a lot of information. It helps me give you an epiphany. It helps me make you understand what's happening on the billiard ball table.
Right.
But it doesn't give you
calling 1 + 1 2, you're not changing the objects themselves. It's always been two things.
It's always been two.
Yeah.
It's a tautology. You're just explaining to me something that's out there already existing. So if I tell you a triangle has 3 points, well, when I said the word triangle, I already told you it has 3 points. But maybe you didn't pick that up. Maybe I had to point it out to you. So Bertrand Russell said it beautifully. He said, look, at first in his career, Bertrand Russell is he's a great thinker. He said, look, mathematics is the thing we're most sure of. By the end of his career, he was like, guys, I'm not even sure about math anymore. Why? He's like, I think math is just another way of saying a four-legged animal is an animal. But you said that when you said it's four-legged animal. And you just repeated yourself by saying it's an animal. If I say, there's my wife, I married her. When I said my wife, I told you I married her. That's what math is doing. Math is giving you the information again in a simpler form that you can understand. And you think, oh, I've deduced this information. No, actually, the information was there in the question.
Right.
Some philosophers disagreed with this. They said, no, math brings you, like Kant. Kant said, no, math tells you something. Okay, let's put that on the wayside. Here's another critique. One I personally could never get around. He says, look, all the greatest thinkers in history, this is actually an Ibn Taymiyyah critique of logic. He says, look, all the greatest thinkers in history all disagree. Like Plato and Aristotle, Plato tutored Aristotle. Mm-hmm. Two of the greatest thinkers in ancient history. They don't agree with one another. They both say you're wrong, and the other guy says I'm wrong. Okay. Fast forward. Every generation, their greatest thinkers disagreed. Leibniz didn't agree with Voltaire. Today, Sam Harris and Jordan Peterson, maybe they're not the top intellectuals of our on Earth today, but they're among the elite. They don't agree on what is true. When you ask them what's truth, you guys are talking about truth all day long. Can you define it for us? We don't agree. So if logic is something that tells us about the world, if it is, let's say we grant that, Descartes saying, look, we can't use it. Nobody's good enough to use it and get to a conclusion that everybody agrees upon. So he's saying, look, even that doesn't help me. So he came up to the cogito. He says, look, he doubted everything. Like he even went to the point where he said, what if I'm dreaming? What if there's a evil demon out there always tricking me? Like he went really out there. Like,
well, that's one of the reasons why simulation theory is tenable.
Yeah.
Like people really do. like serious people consider the potential that not only is it possible that we are in a simulation, but that there are many, many simulations inside of simulations.
Because we couldn't, that's what the egocentric predicament we were talking about earlier is. You cannot experience anything outside of your consciousness.
Right.
So you could be plugged into a machine right now, and this is just a big old dream.
Could be.
And that's why Descartes wanted to know what would be true, even if I was in a simulator.
And that's, I think, therefore I am.
Therefore I am, because for me to have thoughts, I'd have to exist. If you doubt the cogito, you've proved the cogito. Because to object to it, you first have to have existence.
Right.
Right. He refined it. I think thinkers refined it later on, and before him also. Many thinkers came to this conclusion. He just did it really famously. He did it
in one sentence too.
He did it in one sentence. He summed it up. That's why if you've heard of Occam's razor. If you use Occam's razor to an extreme, if you go to an extreme degree, everything with a doubt, you chop it. Everything that might be imaginary, inferred, logical, empirical, you chop it. What happens? You have a transcendent experience. If you take off all your paradigms, and this takes a very brave human being to do, to remove everything that anybody's ever told you and have the experience of the one thing. What you would know, what you would come to, what mystics, that's why I believe that there's a place where you can get where religion is true and science is faith. And I know it sounds crazy, but there is a point, and I believe in science. Don't get me wrong. I can't praise science enough. But there is a transcendent experience a human has. And that transcendent experience is consciousness itself, not the content of consciousness. This is where people make a mistake. Consciousness itself, reality, your world is nested in consciousness. People think consciousness is within my brain. It's the opposite. Your brain, your body, yourself is in consciousness. And when we get to this point, then all our paradoxes disappear. There's no more paradoxes, logical paradoxes. Maybe if we have time, we could talk about logical paradoxes. They never end. But when we understand that our world is nested in consciousness, there's nothing happening in the world around you that's outside of your consciousness. It's only outside of your ego, the thing you associate with Joe Rogan is also happening inside your consciousness. Your brain is within consciousness. No brain has ever been observed outside of consciousness. See, in materialism, they have this philosophy called epiphenomenalism, that the consciousness is a byproduct of this physical brain. We have this physical brain, and your consciousness is like a byproduct. It's like a smoke. Now we ask them, how do you know about this physical brain? Oh, we know it because of our consciousness. So if your consciousness is fake, unreal, then so is your brain. Your brains, the reason why we all know about brains is because of consciousness. Consciousness tells us about brains. So brains are dependent on consciousness, not consciousness dependent on the brain. So I know this is a bit of a tricky thing, but this is what idealism is all about. There is no physical object outside of consciousness. It's all mental construct. We started this podcast talking about MMA and we ended on a mind fuck. Yeah, seriously.
This is a serious mind fuck.
The egocentric predicament, not an easy one.
Well, it's a fascinating yet impractical exercise because you will do it to the end of time. You'll be sitting here debating and discussing and dissecting but that's also how you gain a greater and deeper understanding of all the things you have no idea what the fuck they are.
Exactly. But it's still amazing to me, like how much is to be explored about what is real around us. Like the world, the reality of the world around us is it's greater than any mystery in existence. That's why for me, I can't read fiction. I only study science, history, philosophy. That's the only thing. Science, history, philosophy, religion.
Because it's weird enough.
No, because they're all trying to tell me, they're all trying to explain the world around us. And that's such a hard thing to do, to sum up. What's reality? Hey, all these philosophies and theories are trying to sum it up. This is reality. And to cross-examine them, for me, is far more entertaining than watching a movie or hearing a fictional story.
Yeah, no, I get it. I mean, it's definitely fascinating and entertaining. And I like fictional stories too, though. I like observing creativity because I'm fascinated by the human experience, and I'm fascinated by what people are able to create out of their own mind. Something like we were talking yesterday about Stephen King, about how amazing it is that this guy just keeps continuing to create these bizarre stories, and that someone can do that, your consciousness, and by putting so much emphasis on creativity and your ability to just write down things that never really happened and paint a picture inside someone's mind.
Now, let me ask you this. If determinism is true, who wrote those stories? Like when you write
His past.
When you write a story on a computer, did the computer write the story? No, you wrote the story.
Right.
But if determinism is true, Steven is just a computer, and his buttons are being pushed by past events.
Yeah.
So that's why, like, one student asked me, hey, you should read a book by Sam Harris on determinism. I'm like, well, can you ask Sam who wrote the book? Who wrote the book on determinism? He's going to say, well, he did. No, he can't write anything. He's determined. So these are old philosophical questions that need to be explored. But they're, like you say, mind-bending,
Very mind-bending.